Okay, so we've got the team class almost done. We've got the ability to add a hockey player to initially prime the list with people. We've got this sense of you can now update somebody who's already on the list by saying, hey, this guy added a goal. That goes and searches for them on the list and does the update. We can retrieve things by position using get and size, or we can retrieve things with a for each because the iterator is there. Okay. While we're at it, let's look at a side effect of having done the sort here. Remember, we put the sort inside the iterator to say when somebody runs a for each, we'll make it so that we rearrange things and they see them in the correct order. What does that do to the get and size functions? It does something a little bit weird. As long as you run a for loop to go through the items in the team, you will never ever force it to sort itself. Okay? It's only because there's no sort function inside the get and there's no sort function inside the size. Eventually, if you run a for each on the thing, instead of using a counted for loop, then all of a sudden we'll go, bzz, we're just going to sort this thing and rearrange all of the places on the list. And now if you were to go back and look at it, position 0 is no longer where it used to be, because it's been sorted in the meantime between when you went and looked the first time and when you go and look in the second time. By position, the positions have changed. Somebody rearranged it. So this one, calling get, if you look at the function here, does nothing to rearrange the list. It stays in whatever shape it was in. But all of a sudden, if you turn around and run a for each on it, that calls the iterator function, and the iterator function is going to sort the list. It puts them in a different order than they were in before. Okay? So the bottom line of this thing is that you can't ever really rely on the order number 0, 1, 2, 3, 4 to be correct, because at relatively arbitrary times in your code it could be rearranged. Okay? So if it were me, what I would go back to this class and do is I would probably totally eliminate the idea of being able to retrieve things by position to force people to always use the iterator when they go through things, because for the most part we don't care about who's the number 5 person on the list. So that positional notation is sort of immaterial. And if we need to get it, there's going to be other ways of getting it. Right? The promise, by the way, of iterators is actually not to do this. And so we're sort of cheating here a little bit. The promise of iterators is, if you go look at what they officially say they do, is that an iterator promises to return all of the things back to you, but it doesn't say anything about the order that's going to bring them back. So technically speaking, it could bring them back, from the end to the beginning, from the beginning to the end, from some jumbled up order. It could randomize them and then give them back to you. Its only guarantee is that if you keep asking, it will keep saying, I've got one, until the point when it doesn't. And so this is really sort of cheating a little bit anyway, in the way that we should probably be using iterators. But it'll work for now. Suppose that eventually in the driver we wanted to remove somebody. How would we go about removing somebody from the list? Talk to my team and say remove. And what are you going to give remove to specify which one you want to remove? What are the 2 choices? Okay, what are the 3 choices, actually? So we'll start out with the simplest one. I don't know or care who they are. I just want to remove position 0 or position 5 from the list. Okay, so you could do positional notation. That's the most direct and obvious, but the problem with that is that you might not be getting the right one because the list is being reorganized every time you call the iterator. So maybe positional notation isn't the best. Option number 2, use their name as the basis for locating them. So I could write this as remove, whoever it was, Daniel Sedin. I might write it like that. What's that one going to have to do internally if it wants to remove Daniel Sedin?
Compare names to all the names of the team.
This one, the implication is that somebody, probably the level below, is going and saying, let me go get the first hockey player, see if their first name matches Daniel, see if their last name matches Sedin. So that would be the team guy who's responsible for that. Okay? Is there a better option than doing that? Use our infamous child slave, and instead of supplying the first name and the last name, let's make one who matches the one we're trying to find. Okay? And so at this point, this is probably this is the traditional coding style, but in the object-oriented world, what you would do instead here is you would provide the one that looks like. Okay? And so the way that we would do this is we would manufacture somebody who looks like Daniel Sedin. They're different because there's a new in there. And we would supply that option to remove to say, just go find the matching one and get rid of it wherever it is on the list.
If you were less strict about what you're searching for in your example, like just say Sedin, for example, without the Daniel, would it actually pull both of them out?
No.
Just
It
the
doesn't.
first one encounters?
If you make your matching less strict, it would do just what you do in real life. If you say remove a Sedin, and you would just go and remove whatever one was the first, whichever one you first encountered would go. And so the matching needs to be stricter than that because there's definitely 2 of them on this team. Okay? So now we know what remove should take. It should be remove and an actual hockey player. So go back into the remove, or into the team class, and we'll write public void remove Now, I could just call this by some name like that because it's really sort of kind of any old hockey player. But that sort of hides the idea, and so I'm going to try to be a little bit more specific here, and I'm going to say match this one, something like that. Okay, just to give the sense of I'm doing a match for it. Okay, so now how are you going to, now we're inside the team class, how are you going to remove it?
It's a for each iterator who finds that one.
You could go through and do the work yourself. So you could go through, grab every single item out of the list that you've got, and you could call that item dot equals the other guy to use the matching function in hockey player to see if there's a match. Or there's somebody who already does exactly that for you, which is index of. So you could search for him and then get his position and then remove by position. Okay, so you could do it this way, assuming there's no errors. We'll call roster dot index of the one we want to match, and assuming that it finds somebody, then you could do roster dot remove that position. Okay, and so that would say, oh, this would come back and say, I found the matching one at position number 5, and then we'll just remove item number 5 off the list. Okay, well, there's a shortcut for that even. Okay, and the shortcut for that is that you actually don't do this, and you just do match this one in here. So there's 2 versions of remove. There's remove by position, and there's remove by matching one. And so if it were me, I would have called the first one remove by position, and I would have called the second version of remove search for and remove, to give the sense of actually search for a matching one and remove, which is what it actually does. Okay, so what they do in Java is they just have two different versions, the idea remove, right? One that takes a position, one that takes an object instead. You can do that in Java because they look different, okay? But in this case, it sometimes makes it difficult to figure out which one you've got, right? So I have to go look and say, oh, well, this is a hockey player, so this is the search for a matching one. If that was an integer, that would be the remove by position. Okay, so you get two variations on the same thing. Okay, what's that one going to use to do the matching? Equals in hockey player. So it does the same thing as index of, really. It's just the combination of the two lines of code that we wrote, except it's combined into one simple method. So you still need to have an equals method in hockey player, otherwise it will never find the right one. It will never find the matching one. Okay, so that's all there is to remove. Okay, so let's see. We've made this driver and we've tested out a bunch of things, and we can now go and we can create our team and we can get all the points for it, and we've got sorting to work by producing smallest to largest points or largest to smallest, whatever it happens to be. And now somebody comes along and says, oh, I don't want it sorted by number of points for hockey players. I want to see an alphabetical list of all the people that are on your team, which would be a reasonable thing to do. Okay? The problem with that is that when we do a sort assumes that the way that you're going to want things sorted is by however hockey player by default does its sorting. And if we look at hockey player, the default sorting for the compare to method says that the one and only way that you can sort people, because there's only one compare to, is by their points and then by their name. And I want it the other way around. I want it by their name and then their points. Oops. So it's really common that there's only one reason for matching by equals to say these are the same or not, but there's lots of different reasons why you would want to organize things differently in terms of sorting an object. So we have to find some alternate mechanism for sorting. So what I'm going to do is I'm going to borrow a hockey player here, and I'm going to stuff it into a new class just so that I can deal with the idea separately, get rid of a bunch of the gunk for you. So I'm just going to drop this thing into a hockey player now that he's mostly complete and tested into a different project. And I'm going to close this up just to make sure I get the right ones. And we're just going to deal with this idea of how do we get hockey players to sort differently. So let me make a new driver for this new class, or for this new project. Include a main with it. And I'm gonna need some test data here for this thing. So I'm gonna go back to our initial, whatever it was it hockey driver? Can't remember which one talked to the list directly. Let's just see, is that the one? There's our array list. So I'm just gonna borrow all of this code that made some test data and dump it into this driver so I've got something to work with. Okay, so there's my Canucks list made with an array list directly. And if I, at this point, do collections.sort on Canucks, I get people sorted by points in some manner. No, now we have to find a different way of sorting. Okay, let's do an analogy here. Yeehaw, here we go again. The way I've been doing sorting, if I'm playing the role of list, is when sort comes along and says, here, I want you to work on this list. What sort does in order to do the job is it goes and it grabs the first hockey player off the list, and it grabs the second hockey player off the list, and I do the introduction and I say, hey, are you bigger than him or not? And if he says he's bigger, then I go, you're the current possible biggest I've seen so far, right? And then I advance down, so it's just like doing min or max, right? Same sort of idea, okay? And so in order to do that, actually let's just deal with min because it's a little easier. So we'll just say, suppose I'm trying to find the smallest. Won't worry about sorting for now because that's just more than one min. So we'll do something like that. So min is, oh, okay, grab the first one, grab the second one. I think this guy's the smallest. That's exactly the algorithm you did for lab 3, right? He's the smallest I've seen so far. Let's advance to this guy. You know, are you bigger or smaller than the smallest one I have, etc. Okay, so that's me, the list, introducing A to B, basically, and saying one of you has to tell me which one is smaller. But I'm relying on the hockey player to make the decision for me. But I don't want the hockey player to make the decision for me because now I want to do it by name rather than goals. So here's the trick. Typical Java trick. I turn around and I say, well, wouldn't it be nice if I could put somebody between me and those two people that instead of bothering to worry about their default would actually go and ask them the questions directly and do the work for me. So I'd like someone in between me and them who I can go say, take these two guys and I want you to find out who's alphabetically smaller. Okay? And so now this guy who's doing the work is going to say, oh, I can't talk to their default comparison. I have to turn around and now ask them the question, what's your last name? What's your last name? Okay, which one of your last names is smaller? Okay, I'll do the comparison that way. Okay? So we're going to involve a third party in doing this work for us of comparing two people that just does it in a different way. So to make that happen, what I'm going to do is I'm going to write a brand new class in this case. And I'm going to call my class hockey player comparer. That's probably a bad name. Alphabetizer. Okay, so here's my alphabetizer class. And now I'm going to write a function inside the class with no data. I'm just going to start and I'm going to write a compare method. Instead of compare2, I'm going to give it a different name. And what I'm going to give it is hockey player A and hockey player B. Okay, so now instead of the old compare to was introduce A to B and let him do the work. The new one is third party, gets both A and B, and gets to ask them each questions. Okay, so the question I would ask is, we'll do it this way, string A last name is talk to A and do get last name. String B last name is talk to B and get their last name. And now how do I do the comparison? The difference between them is one compared to the other. A last name as a string compared to B's last name. And whatever that difference is works for me, so I'll just send that thing back. Okay, so that's just this person who you give him 2 hockey players, and he goes and he says, oh, I think this one is better, in this case alphabetically. He did all the talking to him. I don't have to know. I just hand him the hockey players and say, here, figure out which one's smaller. Okay, you with me on that? There's the third party. Now I have to integrate the third party into the sort function. And so what I'm going to do in the sort function, or the min function in this case, is I'm going to add, and I'm going to do it this way to make it a little bit obvious. I'm going to say I'll make my hockey player alphabetizer object and we'll call it alpha sort or alpha comparison. I'll actually do it this way, last name comparison is make our new hockey player alphabetizer better get it right. So I get for choosing such a long word. So I'm going to make my new hockey alphabetizer guy, and then what I'm going to do is I'm going to take him and I'm going to add him as an extra argument onto the min function, saying, hey, look, when you're searching for the smallest one, don't use the default for hockey player. Go talk to this guy instead and let him do the comparisons for you. Okay, so that's just an option. Don't do the standard, use this guy instead, and he'll tell you how to organize things. Just all you got to do is present him with A and B, and he'll tell you which one's smaller. Now, the one last trick to this game is we get this nasty, another one of these gobbledygook messages. But notice in the gobbledygook message it has this word comparator. And the thing is trying to tell you that in order for it to use that thing, you have to announce that that compare function that we wrote is just available. And so the alphabetizer class is missing the announcement that the compare is there. And so we'll go into the alphabetizer guy and we'll write another one of these implements guys, implements comparator, not comparable, but comparator for hockey player. Again, if I can spell it correctly. And you'll need the bulb to do the import statement, and it's another one of these Java util things. And now all of a sudden this class is happy, and now all of a sudden the other class is happy. Okay, and if we go and print them out with a for each, in Canucks, go through all the players in Canucks, and we'll just print out, I guess we'll do all of it. Well, for now we'll just print out who and hope we've got a two-string in there. Let's see what happens. What does that mean? Ah, damn, no two-string. So I guess let's go for the who dot get last name plus who dot get first name plus who dot get total points. So we can see all the important stuff. Give that a try. And now we've got, hopefully, the K's and the S's. Oh, we added Kessler first. Well, we can fix that. Which order did we add them in? We added Kessler first. Let's just play a little game here of adding Kessler last instead of first. Shouldn't be on the list twice. And we'll see whether or not we get them alphabetized. Oops. I was just going to, oh, sorry. I just wanted the smallest one. But hey, now that that works, instead of getting the smallest one, I'm just going to do this. If the smallest one works, I didn't even check, then collections.sort is just min all over again. So we'll go and sort the Canucks, which is what I meant to do before we print them out. Won't bother about what min is. Run it again, and now they come sorted out by what?
Did you put points more chooses? Do you need
Oh, yeah, sorry. Good call. That was the default sort. Instead of using the default sort, let's add the extra argument on there for the special version of sorting instead by last name comparison guy. Let him do the work. And now when we sort it, they come out that way. What about the Sedines? We want to make sure that they get in the right order all the time. Okay, so right now if I add them in the wrong order, oops, cut that one out of there, and paste them in at the end, for instance. So I've got Henrik before Daniel, but I want it the other way around when they sort. Right, they're in the wrong order now because it should be, now since their last names are the same, we should go to a first name comparison. So we can go back into the alphabetizer and we can extend this thing to do the game of, just like we've done with the other ones, if the difference is not equal to 0, meaning they're already different, we can send that back. Otherwise, we'll use the difference on the basis of their first names and send that back instead. Oh, need to do the get, that's okay. Steal this code because that was last name, and add in the, let's just retrieve them and put them into a first name. B first name. Do it that way.
You're still gonna change your gets.
Oops, what did I do?
Get versus
Oh, gets, thank you. That should be first. That should be first. Save it. Run that version. Things are a little slow for the moment. And now they come out in the right order. Okay?
I guess depending on the application, you can do as many steps as.
You can, I mean, we could extend this one to be points, would be the next obvious thing, in case the Sedines both had the same number of points, right? Then you would want them, I don't know, you extend that whole idea as much as you want. The other thing is that we can take this same concept now. This is actually alphabetizer by last name. Suppose that we wanted the friendly version of the sort. I want to be able to call students in my class by their first name, so I'll do the friendly sort that has them sorted by first name and then last name. right? What we can now do is you can take this entire class and you can just flip this, you can make a brand new class that's hockey alphabetizer by first name. You just basically copy paste this entire class, change the order of whether or not you do first name or last name, and then in your driver, instead of making the comparison guy that does that version, you give him a different comparison guy that does the other version. Okay? And so now every time you want to make a different comparison, you have a different comparison guy who's in charge of talking to them and figuring out the right way of comparing those two guys by asking them questions, and then you just pass that on to sort and say, here, use this guy instead. And that's all there is to it. Okay? Now, the only problem with this is that this is, let me ask the question this way, where does this alphabetizer really belong? We wrote this as a class standing all by itself, right? But it's really only ever in its life going to be concerned about hockey players. It's never going to be concerned about fish or ducks or students or anything else. And so if this was a belonging thing, he's now sitting out here, where does he actually belong? Belongs in the hockey player class. And so the next step of this game is to, instead of leaving this class out stranded there, not associated with hockey player, we're going to tomorrow bury him inside hockey player and say, hey, look, if you're writing the hockey player class, it makes sense that instead of just providing one mechanism for sort, you should provide multiple mechanisms for the common ways of sorting so that nobody else has to do that. And so the regular position will be to put this class inside the hockey player class for the belonging sense, but this option of external will always be available. So the fallback position, in case somebody didn't bother to write them for you in the hockey player class and they're not available, is that you can always go write the thing to query them any way you want yourself directly and then do the work of the sorting outside of the class. Not as good, but at least the option is there. So that's what we'll do tomorrow, is we'll move these things inside, and there's some associated weird mechanics with doing that. But at least now you can go forth and sort in any way that you want. And that's it for today.